In our last segment, we broke down why relying on a single overloaded prompt is a recipe for failure in complex AI tasks. The solution, as we discussed, is prompt chaining. That is, a modular approach that breaks a complex workflow into smaller, manageable steps. And today, we're going to see this concept in action by building a two-step pipeline in Python using LangChain Expression Language or LCEL. Our goal is to take a piece of unstructured text, basically talking about a laptop specs, and transforming it into a perfectly structured JSON object. So we'll do this in two steps. In step one, we'll use our first prompt to simply extract the technical details, and in step two, we'll then feed those extracted details into a second prompt that will handle the transformation into the JSON format. This demonstration will clearly show how the output of one LLM call can be reliably processed and directed to the next, creating a predictable, powerful AI agent. The very first step is to create a Python virtual environment to isolate your project's dependencies from your system's global Python packages. So this command creates a new directory named myvenb that holds a clean Python installation and its own set of pip package manager. Now we activate the virtual environment in this machine. Now that the virtual environment is activated, we can create our requirements file. So the requirement file will list all the Python packages that our project needs to run, ensuring that anyone, including myself later, can easily install the exact dependencies. So we'll create a plain text file named requirements.txt and then add some package names, one per each line. Once this file is saved, we can use the command to install all of these dependencies into our activated virtual environment. So this command tells pip to read the list from the file and download and install all the required libraries for our project, including the core LangChain library, the foundational LangChain core package, and the specific connector for Gemini models, LangChain Google Gen AI. So after this, the next crucial step is securing our API key. We can secure our Google API key from Google AI Studio, and then we'll create a .env file to safely store our confidential credentials. So in the root directory of our project, the same place where our Python script and requirements.txt are located, we'll create a new file named .env. Inside this file, we will define an environment variable called Google API key and assign our actual API key to it. For security purposes, I'm not going to show you my API key. You need to do that on your own from Google AI Studio. But why use a .env file? The .env file allows us to load sensitive information like our API key into our program's environment variables without hardcoding it directly into our source code. This practice is essential for security. If you share your code publicly, example on maybe some Git platforms, you can easily add the .env file of your projects to your gitignore file. This prevents you from accidentally committing and exposing your private API key. Now we'll create our main application file say app.py, where we will start implementing the prompt chaining logic. We start by importing the Chat Google Generative AI class, our specialized connector that lets us use the powerful Gemini models. Next, we bring in chat prompt template, and this is how we define the structured, reusable prompts for each step of our chain. We also need the str output parser to take the LLM's complex output and convert it into a simple, clean string that the next prompt can easily read. And finally, we use load_.env to automatically fetch our Google API key from the secure.env file. After this, we call load_.env function to load our Google API key into the environment, securing access to the Gemini model. Now, we initialize our language model, creating the LLM object using the powerful and the fast Gemini 2.5 Flash model. We first define prompt 1, the extraction prompt, which tells the LLM to pull out the technical details from the initial input text. And we also define prompt 2, that is the transformation prompt, which will instruct the LLM to structure the previously extracted specifications into a perfect JSON object. Now we are ready to build our chain using the LCEL, which uses the pipe operator for clear sequential steps. Now we define the full chain, which links the extraction step directly to the transformation step. Here, extraction date or the specification part is the key. We map the output of our extraction chain to the required input key specifications for the next prompt. We now define our input text, the unstructured product description we want the chain to process. Next, we execute the entire pipeline using .invoke function, passing our raw text to the full chain to get the structured result. And finally, we print the final result, which is the clean, validated JSON object transformed by our two-sweep prompt chain. Now, we can run this code and see if we get the expected result as per our prompt chaining process. I might have missed a library in our requirement, that is .env. Let me reinstall, or I can directly install .env here if it's available. Now let me run my code again. And as you can see, we got our structured JSON output with the intended keys that we wanted, which is CPU, memory, and storage, and then the exact values corresponding to those keys are also extracted here from the unstructured input text. So that is it. We successfully implemented a two-step prompt chain using the power of LangChain and the Gemini model. We saw how breaking a complex task from unstructured text to structured JSON into a simple sequential flow dramatically increases reliability and control. The output of our extraction prompt became the precise input for our transformation prompt, resulting in a perfect predictable outcome. And this modular approach is the foundation for building advanced AI agents